Okay, hi, welcome again everyone to our pre-calculus class. We're going to start with some review on right triangles. The first semester we're going to cover is the trigonometry section, and then the second half is our math analysis section. So let's go and get started as we talk about trigonometry. Trigonometry, and the big word here is the tri and the kind of geometry part. Trigonometry, I think is spelled it right. The tri refers to three because we're dealing with three-sided shapes. And for the first couple months, we will be focused on three-sided shapes. Three-sided shapes are a big deal in geometry because it's kind of our starting point to talk about all our other shapes. And there's a lot of relationships we can see in a three-sided shape. Let's look at some characteristics for now. One, if I just draw any three sides, we can automatically say that the angles, let's call it angle A, B, and C, they always add up measurement of angle A plus the measurement of angle B plus the measurement of angle C always add up to 180 degrees. So that's a simple one we talked about before. For our first lesson today, we're going to look at special triangles, specifically what we call a right triangle. And the right triangle is special because there is a 90-degree angle that takes up pretty much half of all the angles that we could use. It's almost like we have a bank of $180, and if I use up 90, we've already spent up half our money. Now, these right triangles have a lot of characteristics that are kind of cool, and we're going to do a lot of them in PreCalc. We're going to talk about our relationships of sine, cosine, and tangent, and as well as the relationships of the sides by themselves with our Pythagorean theorem today. And the Pythagorean theorem is this condition that says if this is a right triangle, then the sides are related by this formula. So if the triangle is a right triangle, let's say triangle is right, then this is true. A squared plus B squared equals to C squared, where A and B are what we call the legs of the triangle, and C is what we call the hypotenuse. Also, C is always the largest side. If you remember the relationships of all triangles, if we have a small angle, we would have a small side. But if we have a big angle, this side would have to be bigger in relationship to our other two sides. So big angle, big side, small angle, small side. And that's always referring to the opposite side. It's almost like the side that the mouth opens up to. If you open up your mouth in a small angle, you have a small opening. If you open up your mouth at a big angle, you have a large opening. So if this 90 degrees right here took up half of all my possible angles, there's no way that the other two angles will be bigger or that those sides can be larger than my hypotenuse. So in a right triangle, the hypotenuse is always my largest side because it has the most dominant angle. As a simple example, if I give an angle 50 degrees and 40 degrees, 50 and 40 degrees, none of those angles are bigger than 90. That means the 90 side, our side C here, our opening side, that side must be larger than our other two sides. So something that kind of logically flows. So this rule of the Pythagorean theorem says if we have a triangle that's right, then this must be true. It's actually what we call an if and only if statement. It goes forwards and backwards. If I have a triangle, if our sides are related by a squared plus b squared equals to c squared, if this is true, if for sure the sides, when we square them, add up to the hypotenuse, then this must be a right triangle also. Then triangle is right. You'll see this if you guys read a lot of theorems. They have a little symbol that looks like a double arrow sign. And this means we can go either way, forward or backwards, because each is a clause for the other part. So let's look at this and give ourselves an example. Let's give ourselves a triangle, a 3, 4, 5 triangle. And the question is this a right triangle? So if this was a right triangle, if we're trying to prove that, would this first statement be true? If 3 squared plus 4 squared, is 3 squared plus 4 squared equal to 5 squared? And if this is a true statement that the left side equals to the right side, then for sure this is a right triangle. And let's go ahead and do the math. 3 squared is 9 plus 16. 5 squared is 25. And 16 plus 9 is 25. That means this is a right triangle. This is actually what we call a Pythagorean triple. Oops. Pythagorean triple. I think there's 2 P's, sorry. I suck at spelling. So a Pythagorean triple refers to 3 sides of a triangle following the Pythagorean theorem, and also them all being whole numbers. So 3, 4, 5 is one. If I want to say 6, 8, 10, how do I do that? Well, if you multiply them all by 2, that would also be a Pythagorean triple. This would be 64 plus 36 plus, is equal to 100, and that's true. Any multiple of 3, 4, 5 would work. Another one is, popular is 5, 12, and 13. This is a Pythagorean triple also. And you can look up Wikipedia. You can find a source that shows you all the different versions of Pythagorean triple. But for the most part, we will always have decimals. Unless if it's one of these few Pythagorean triples, most of our problems will be in decimals or radicals. Okay, so we proved that this theorem was true. The Pythagorean formula is true. Then that means this was a right triangle. Well, what if I give you guys a problem with a fancy square root in it? So if I say, let's do Let's do 9, 4, and this would be 97. Okay, would this be a right triangle? So which of these sides would be the largest? Would the 9 be the largest? Would the 4 be the largest? Or the square root of 97 be the largest? So you can square it. If I square 4, that'll be 16. If I square 9, that'll be 81. But if I square 97 to get rid of the square root, this would be 97. And 97 here would be our largest side. So we would have to set up as the 2 shorter sides would have to equal to the largest side. And one of the cool things about the Pythagorean theorem, that even if you do have a square root, when we square it, it gets rid of that square root. So 16 plus 81, does that equal to 97? 4 times 4, 9 times 9, square root of 97 squared is just 97. And this becomes 97 equals to 97. Yep, that's a right triangle. We can work backwards, and oftentimes, the most time that we use the Pythagorean theorem is when we're trying to look for the missing side. What would that side be? If I say 5, 7, and what would this third side be? Now, as I see it, can I use the Pythagorean theorem? If I just walked into the forest and saw this triangle?
No.
And the answer is
No.
No, that's right, thank you. You can't use it. There's not enough information. We have to follow the rules of math, and the math the rules in math are important. So the rule that we were going to use is this guy here. Is this a right triangle to begin with? Let's see. Not enough information. This is not a right triangle. That means you cannot presume that you can use the Pythagorean theorem. I'm sorry. So let's go ahead and force it. If this is a right triangle now we can use it. So to look at it, what side is the hypotenuse? Some kids, I don't know why, but some people had issues finding the hypotenuse. Maybe we might draw the hypotenuse in a couple different ways. If I draw the triangle this way, or if I draw it this way, oops, this way, let's fix that. Or maybe even this way. So if I spin the triangle around, sometimes it messes up your orientation. So the hypotenuse is always the side opposite of the right angle. It's always opposite of the right angle. Is always opposite. Remember, the right angle is your largest angle, and the hypotenuse is also your largest side. But a dumb trick is, if you're not sure, draw a little arrow. If you guys see a little corner here, draw a little arrow. Where's the hypotenuse? Here I am. Where's the hypotenuse? Here I am. Where's the hypotenuse? Here I am. It's always across from that angle, and it's pointing right at it. It's kind of silly, but some people need it. Okay, so where is my hypotenuse? Here I am. So the hypotenuse is here. So we have to set up as a squared plus b squared equals 2c squared. Always that formula. Always the sides, the legs, add up to the hypotenuse squared. So you can choose 5 or 7, it's up to you. Oops. I'll just do the math in my head. Equals to c squared. So we're left with 25. 7 squared is 49. And we're left with a c squared. Adding 25 plus 49 is 60, 74. Equals to c squared. To solve for c is my hypotenuse. C squared is what we have. So we're going to take a square root on both sides. Which leads us to c. Now, we normally would, if this was an algebra, we would claim this could be a plus. Oops, this is ugly. This could be a plus or minus. That's what we always do. Whenever we take a square root, we always claim a plus or minus. But looking at this triangle, would this ever be a negative value? No. Nope, not if that was a real triangle, right? If that's a real triangle, it will never be negative. So we can ignore that negative possibility and just write the square root of 74. We could try simplifying this square root. Maybe you guys forgot how to simplify square roots, but I'm going to go ahead and draw my box method. I draw a little box method here, and I write 74 inside. And I start to factor 74. What's the smallest, not the largest, the smallest number I can divide 74 by? That is a 2. 2 goes into 7 3 times, remainder 1. 2 goes into 14 7 times. 37 is, to me, a prime number. I can't think of any number I can divide 37 by. So there is no pairs. We are done. H is square root of 74. And if you do the square root in your head, square root of 74, just so we kind of get a value, 74 is between 81 and 64. So the square root of 64 is 8, square root of 81 is 9, so 74 is 8 point something. Okay, 8 point something. That's all we have to estimate. This is 8 point something. Is 8 point something bigger than 7 and bigger than 5? Yep. So at least that's one of our check marks that we can make sure we're on the right track. Hypotenuse has to be bigger than our other two legs. Now, this is kind of cool. Like, because we have 3 sides and we have a side that we know for sure, the right angle, everything kind of bends and flows And it's almost like a dance. If you move, I move, and then we move. So in the triangle, you can imagine that if, I'll call this A and B and C, if my A got shorter, C would get shorter. And they're actually increasing and decreasing in a proportional rate. Like there is actually a relationship of how much they're increasing and decreasing. If we saw the other way, A and B, if I decide to shrink B, B shrinks and C shrinks. And there's a relationship that we can come up with. And part of trigonometry is talking about that relationship. As angles move, as sides move, since we're stuck in a right triangle, we can totally predict how we are going to move. This isn't like the weather where you say it's going to rain or not going to rain. There is actually a ratio that can predict what that change will be. And that's where sine, cosine, and tangent come in. So our big takeaway today is our Pythagorean theorem to say, hey, there is a relationship between these three sides. Now, if there's a change in this or in any of the sides, can we then predict what that change would do to the rest of the sides? Let's do one more practice problem today. And this is just a square root problem. Let's call this the square root of 6 and call this 4. This is a right triangle. Now, what would my C side be? Let's go try that. First question, is this a right triangle? And the answer is yes, this is a right triangle. That means we can use Pythagorean theorem. Pythag theorem is totally okay to use now. So a squared plus b squared equals to c squared. We want to make sure we identify which side is A and B. It doesn't matter which side you choose A and which side is B, but for sure, you can't mess up with C. C is always my hypotenuse. And you figure out which side is that, is the arrows pointing at it. Here I am, I'm over here. I'm the tallest guy in the room. So that means this could be A, this could be B, or vice versa. Those are interchangeable. The legs are always interchangeable. So I can write 4 squared plus the square root of 6, parentheses squared, is equal to c squared, whatever that may be. 16 plus, now again, the square and the square root, they cancel each other out, which is making my life a lot easier. C squared. 16 plus 6 is 22. We take a square root to both sides. The opposite of a square is a square root. We don't need the negative version because we're not going to have a negative side here. Now, we can write c is equal to the square root of 22. Now, let's go ahead and just verify in a very simple manner, is C my largest side? Okay, A is 4, B is about, what is square root of 6 about? Square root of 6 is between the square root of 9 and the square root of 4. So this is going to be 2 point something. 2 point something. We have, so 2 point something. Square root of 22 is between square root of 25 and the square root of 16. That's going to be 4 and 5. So this is 4 point something. So is my hypotenuse bigger than my other two legs? Yeah, even though it's a tiny bit. Yeah. Okay. So let's do a quick problem real quick where all our problems, all our sides are roots. If this is a root 4, root 5, what would my hypotenuse be? So we would set it up. Since it is a right triangle, we can square the legs. Square root of 5 squared plus square root of 4 squared is equal to c squared. Or you can think of it as a squared plus b squared equals to c squared, where the legs are a and b. So that would be square and a square root cancel out, leaving me an easy 5, and easy 4 because a square and a square root cancel out. becomes c squared. And 9 equals to c squared. We take a square root of both sides, square root of 9. So it turns out our hypotenuse here is a simple number 3. Lucky us. Now, does this still fit what we said? The hypotenuse is my largest side. A square root 5 is approximately square root of 5 is between square root of 9 and square root of 4, which is a 2 and a 3, so it's 2 point something. Square root of 2 is 2. So 2 point something and 2, and definitely 3 is bigger than those two sides, just to double check if we're kind of at least in the ballpark.